Okay.
In this session, we are going to discuss about local search algorithms and heuristic search technique, one of the heuristic search technique, that is hill climbing. These two are the parts of introduction to AI and data science. So here we are in this session we are going to discuss about what is a local search and different types of hill climbing technique also we are going to discuss. After completion of this session, you will be able to know what is a local search algorithm and what are the different variants of types of hill climbing techniques. So first we will discuss about local search algorithms. This local search algorithm, in this search, when we are starting from a source node and we are going to get the goal node, this search algorithm will try to find the path or answer node by keeping a single node in memory, and when it reaches the goal state, entire single node which are kept in memory will be clubbed together to get the entire path. For example, if we want to this is the goal node, source node, and we want to, this is the goal node. So from this node to this node, if we want to, in between there will be many nodes. So we need to traverse or we need to find out different nodes, right? So suppose this local search algorithm will start search from this place and we will find out only in the neighborhood of this node, whatever the neighborhood, next neighborhood, will find out the best path in the next neighborhood only. So we'll take this one and we'll keep this in memory. From this node we'll search only in the next neighborhood. We don't go for the entire search space, we only search in the next neighborhood. From here we will try to find the best path, and we also keep this node in memory along with the previous node. This process is continued till we get the goal node. Once this is done, we'll club together all the path, all the nodes in the path which we have kept in memory, and we'll show this as a answer path to the goal state. This is a kind of local search. This is known as local search. And also this local search is always not the case of keeping the entire path in memory. So some problems may have total path as the answer, and some problems may not have entire path as an answer. For example, if you take 8 queens problem, this 8 queens problem, we need to arrange the queens in the rows and columns in such a way that no two queens attack each other. So however we arrange the nodes, what the answer will be? The answer will be the final state of the board, how you arrange the queens. There we don't consider all the paths that we made as an answer, but we will consider only the final state of the board, how you arrange the queens in the rows and columns by satisfying all the constraints. So it may be the entire path, answer may be the entire path, or it may be the final state. Both can be answers in dependence on the problems we solve. And one more thing is, here we consider only a neighborhood of the present situation where we are in order to find out the goal state. Step by step we process till we reach the goal state, and this kind of problems will be useful in applications like integrated circuits design, factory floor layout designs, job shop scheduling, automatic programming, telecommunication networks, and vehicle routing, etc. All these can be the applications of this kind of local search algorithms. And this local search algorithm will operate, as I said, this will be single current node. These will operate using single current node. And here the path, entire path is retained till we reach the goal state, and that will be shown as answer. And these are not systematic. These local search algorithms are not systematic. Why? Because we use various kinds of heuristic functions or any kind of search technique in searching in the local neighborhood, like BFS or DFS. Whereas in those search techniques we always go through breadth-wise or depth-wise in order to go to the goal state. Whereas in this local search algorithm there is no particular pre-constraints, like you have to go in this way only. There is no such constraint. We can follow any of the path in selecting the next best node in the local neighbor, and it depends on the problem and the logic. The search strategy changes from problem to problem, so it is not systematic. And the advantages of these local search algorithms are they use very little memory, because only we consider one node in the neighborhood at a time. It requires very less amount of memory. And also, if even the search space is very large and infinite, these local search algorithms can give reasonable solutions, right? So these are all the advantages of local search algorithms. And these local search algorithms, along with finding the goals and finding the goal by considering the local nodes in the local neighborhood, these are also known as optimization problems, because these local search algorithms, different variations are there, and these local search algorithms will try to find the optimized solution. Either it can be a global maximum or global minimum. It will try to find the optimized solutions, and these algorithms will definitely give you a solution if answer was there for that given problem. If a given problem has an answer, these search algorithms will definitely find a solution. These are all the important points to keep in mind about local search algorithm. And regarding heuristic search, we already discussed in the introduction to heuristics. One example of this heuristic search and local search algorithm we are going to discuss in this session. That is hill climbing technique. Hill climbing technique is an example for both local search algorithm as well as heuristic search algorithm, because we use a particular heuristic in order to find the best node in the local neighborhood. So we are applying both the techniques here. We are searching in the local neighborhood as well as we are using heuristic search to find the solution. So this is local search as well as heuristic search algorithm, hill climbing. And this hill climbing can be called as informed search algorithm also, because the existing cost or whatever information is given, we were trying to manipulate that information and to get some value out of that manipulation, and we use that value in order to find the solution for the goal. So it is informed search algorithm. So hill climbing search technique is an example of informed search as well as local search as well as heuristic search algorithm. And there are two different variations of this algorithm. The basic one is simple hill climbing. Apart from this, we have two more techniques of this hill climbing, that is steepest ascent hill climbing and stochastic hill climbing. And we completely learned about simple hill climbing, and we'll also discuss about steepest ascent hill climbing. Stochastic hill climbing, we will see only the introduction part. I will only tell what is stochastic. We are not going to discuss this entire stochastic hill climbing in this session. We will discuss about simple hill climbing. And this is the algorithm of the simple hill climbing, and I'll explain you the steps in the simple hill climbing. That is so first, when we are starting from the current state in the hill climbing, we will select from the source node, right? Suppose if you want to find a path from the source node to the goal state, we'll start at the source node, and